Hello everyone, this is Mrs. Lindsay. Today we're going to talk about natural logarithmic functions. Again, we've been reviewing this already in class, so some of this will be review for you, but it's also a very good refresher. So again, natural logarithms, so ln of x equals b. If you recall, that is actually where you have base e, so you would have log base e of x equals b. Again, you don't typically ever see it written that way. It's always written with ln, but that's what it's assumed to be, base e. That's the logarithmic form. Rewriting an exponential form is e raised to the b equals x. I would like you at this point in time to go ahead and graph y equals ln x and then make the table for those x values. When you're done, go ahead and push play to check your answers. Okay, so here's your table and your graph, and hopefully you remember to graph your asymptote. Again, that's an important part of the graph there. And let me move this down. So hopefully you filled in 1, 2, and 3 as well. Domain is 0 to infinity. Range is all real numbers. Again, you could have wrote negative infinity to positive infinity. Notice this function is continuous, increasing in 1 to 1, and a little refresher on 1 to 1. It's a function for each y value in the range. There is one corresponding x value in the domain. And then it is concave down. So again, let's keep going on with graphing here just a little bit. In this case here, I went ahead and graphed the parent graph, which we just did on the previous screen, y equals ln of x for your reference. And then let's think about transformations. I know you can plug this in your calculator, but how would, for example, this first graph, y equals ln x of the quantity x plus 2, change from our parent graph? Well, it's inside the parentheses, so it would have the opposite effect on our x's, so it would move everything to the left 2. So I can simply just count, again, asymptote, move that to the left 2, as well as my reference point here, which is 1, 0, move that to the left 2. And I should be able to graph my transformation. So I would like you to go ahead and think about the transformations for the next two and try those on your own. Push play when you're ready to check your answers. All right, so the green one here, so y equals ln of x plus 5. So again, it's outside, so have the normal effect on your y, so everything moved up 5. The vertical asymptote stayed the same. And then here, if you recall, where we do 2 times ln of x, remember you're not changing your x's at all, but what you're doing is you're multiplying all your y's by 2, so you're doubling your y's, so that's a vertical stretch. So that's stretching it vertically, and again, still your vertical asymptote remains at x equals 0. Okay? All right, so let's move into some inverses of exponential and logs when their bases match. So again, kind of a little bit of review. We've been working on this in class as well. So here we have ln of x equals 3. So remember when ln, that's a log base e, when these are the same, we kind of think of it as canceling. They're really not canceling, they're inverses of each other, but that simply would become 3. Okay, so same idea over here, ln, same base of e raised to the x, so that would just become the exponent of x. And then if it reverses, so I'm going to do this one over here on the right, e raised to the ln of x, doesn't matter which one is the exponent here, so ln of x is our exponent, it has the same base as e, so again, those, so to speak, cancel, really they're inverse of each other, so that would remain just x. And again, over here, that would remain the same, e raised to the ln of the quantity x plus 1 would simply be the quantity x plus 1. Okay. Let's investigate, though, actually why this works. So I'm going to take this first example here. If I set that equal to x, and I said solve for x, hopefully you would take a look at this and say, you know what, I'm going to rewrite this in exponential form. So I'm going to take ln, which is base e, so it'd be e raised to the x equals e to the 3. So again, here the bases are the same, therefore the exponents must be the same. So again, a small little proof of why that actually works. All right, let's continue on a little bit more with our logs here. I would like you to pause this because we have actually talked about this already. See if you remember the properties of your logarithms here in terms of expanding. So take a minute and fill this in, please. Okay, so again, we're going to be able to go both directions with these properties of logs, condensing and expanding. So let's try some more examples of this. Let's do the first one together here. So this one says, write the expression as a log of a single quantity, or again, you might see some of the directions that say condense. So you can see we have two logarithms here, base e, so we have ln's. We want to use our properties. We're going to go the reverse direction. We're going to take everything over here on the right and convert it back to the left, so it's one single logarithm. So hopefully you see the numbers in front here. So we got to undo our down and fronts first. So we need to bring those up. So we'd have ln of 3 squared minus ln of the quantity x squared plus 1 raised to the half. Now we can take care of our subtraction. So again, we're really just following our order of operations like we typically would. Got rid of our multiplication. Now we're working with our subtraction. And if you remember, subtraction is turns to division. So ln of 9, so I took 3 and squared it, over the quantity x squared plus 1 raised to the half. Now one thing I do want to point out, I would also take this answer, realize that these are equivalent to each other. So if you see you have it written one way and when you check your answers in the book and it has it written another way, realize that they are equivalent to each other. Either would be correct. Okay, I would like you to try this one on your own. My hint with this is be careful with your parentheses here. We got a few different parentheses. But try this one on your own and then push play when you're ready to check your answers. Okay. So check your answers again. You could have it written in either form there. I do want to point out again, please make sure, sometimes we try to skip too many steps. So if you need to, take one step at a time, get rid of your down and fronts. You might get rid of your addition there, then your subtraction, kind of did that all in one step there. So if you're noticing that you're kind of missing some steps or when you're checking your answers, slow down and write out all the steps so you get them correct. Okay. So this was condensing, writing as a single log. Now let's actually practice expanding here. So again, we're now going to go reverse. Write ln into as many logs as we can. So let's go through this one again, and hopefully you remember what we just went over, the answers of how we could put it in two forms. Square root can be written as an exponent raised to the half. Now I can do down and front with that. And again, we want to get rid of all exponents, all multiplication, all division. So here we have multiplication. So now we have ln of x, and we can change that into ln of x plus ln of the quantity x plus 1. Now we have to be careful of this a half because the square root affects the entire quantity. So we can do one of two things. We can either put brackets around the entire thing, or, and again I will take either answer here, you can distribute through the half to both of the ln's there. Either will be sufficient for those. So I would take either answer there. Alright, I would like you to try the next example on your own and then push play to check your answer when you are done. Alright, there's the answer. And now we're going to move on to solving exponential and log equations. So please notice here that in this case, these are exponential with related bases. Okay, so in other words, 4, and can I get this to be 4 raised to some power? Well, we know 4 to the third is 64, so we can rewrite the right-hand side as 4 to the third raised to the 3x. Now we got to think about our properties of exponents. A power raised to a power, we multiply. And now we have, again, the bases are the same, therefore the exponents are going to be the same. And now it's just a matter of solving. So x is going to be 6. Okay, so again, that is where your bases are related. Let's take a look where we have unrelated bases of exponentials. So again, this one we want to think about what can we do here. Well, we want to write it in exponential form. So first we want to subtract over the 10. So again, write in exponential form. And then we're going to take ln. Or you could take log of any base of both sides. But in this case, since we see we have base e, it definitely makes it a little bit shorter process if we take ln of both sides, because again, these have the same bases, so they're inverses of each other. Therefore, they cancel each other out, and it would just be 5x equals ln 4. And then you can simply divide by 5. I'm okay with leaving your answer like this, ln 4 divided by 5. That is exact. If you also wanted to put that in your calculator, that would be appropriate as well. It would be approximately 0.277. So either of those answers would be fine. Okay, so now moving on to logarithmic equations. Here's where we have logs on one side of the equation. In this case, we want to make sure it is written in log form. So in this case, it is already. So therefore, we want to convert to exponential form. So this is base 36 raised to the half equals 2x minus 3. And now we have a nice little equation where we can solve. This is, again, is really the square root of 36, which is 6. And then we can solve from there. So x equals 9 over 2. Okay. And this one, I would like you to go ahead and pause the video, try this one on your own. You do first need to condense, then convert. Condense, then convert. So go ahead and pause the video and try this one on your own. Okay, so condense, convert to exponential, then we had to factor. The one thing with this is you should check your answers, because you cannot take the log of a negative number. So if I plug in negative 8 here, I'm taking the log base 2 of a negative number. That will not work. Only 4 will work. So make sure you just plug those back in and check your answers. And the last type of examples that we're going to do here, again, it's another log. This is where we have log on both sides. So in this case, they're both simplified. So I have one log on one side, ln of 13p minus 2 equals another log, ln of p squared plus 4. So again, what happens is 13p minus 2 would equal p squared plus 4. So again, the ln's, so to speak, cancel each other out. And we're going to have to factor again. Bring everything over to one side. Factors of 42 that add up to negative 13 would be negative 6 and negative 7. So p would be 6 and 7. And again, if I plug those in, I would get positive numbers on both sides. So those would both work. Okay. So the next example I would like you to try as well. Again, remember condense, and then you can have log of something equals log of something, so the two somethings are equal to each other. So again, go ahead and pause this video, try it, and push play when you're ready to check your answer. Okay, so we had to condense first, so we got rid of the down and fronts. Then I went ahead and squared the 4 and took the cube root of 8, and that subtraction turned into a division. So again, log base 6 of something equals log base 6 of something, so the two somethings are equal to each other, and therefore x is 8. And this concludes our lesson and review on logarithmic and natural functions.